After a 6-week wait, our order of 4 Interbotix robotic arms from a US company finally arrived. Why choose a US-made robotic arm over a Chinese-made one? Chinese-made robotic arms offer comparable functionality and performance to their US counterparts at a significantly lower price, over 50% cheaper, and with much faster delivery times, typically arriving within a week. There are 2 reasons for using a US-made robotic arm. 1. Research focus. The ultimate goal of our project is to study Stanford's Aloha motion planning model, which is a software-centric approach that doesn't place a strong emphasis on the robotic arm hardware itself. To minimize the learning curve, we opted for the same robotic arm model used by the Stanford Aloha team, the Interbotix robotic arm. By using the same hardware, we can isolate any issues encountered to our software rather than the robotic arm hardware itself. 2. Reduced learning complexity. During our work with the Interbotix robotic arms, we found them to be highly amenable to programmatic control, thanks to the well-designed system architecture and APIs provided by Interbotix. Manipulating a single Interbotix robotic arm with Python. We began by controlling a single Interbotix robotic arm using a Python program, instructing it to perform a sequence of pre-programmed actions rather than actions learned by an AI model. Objectives: familiarize ourselves with the Python API and ROS2 robotic operating system for controlling Interbotix robotic arms. Learning resources. The US manufacturer has open-sourced the software system for Interbotix robotic arms on GitHub, including several usage examples to facilitate user learning. Single arm control procedure. 1. Initialize the robotic arm. Launch 2 ROS2 nodes. SDK node handles direct control of the robotic arm. Simulation node simulates the arm's operation in the RVI's visualization tool to minimize errors during actual execution. 2. Control the robotic arm with Python. Utilize a Python program to command the robotic arm and execute a series of actions. Dual arm operation. Dual arm operation differs from single arm operation in 3 key aspects. 1. USB port mapping. Each robotic arm requires a dedicated USB port on the computer, resulting in 2 USB ports for dual arm operation. Therefore, the mapping of 2 USB ports is necessary for dual arm control. 2. Package utilization. Interbotix provides multiple packages, including one for single arm control and several for controlling multiple arms simultaneously. In this experiment, we did not modify the packages provided by Interbotix, but it remains unclear whether modifications are required for the packages in the context of Stanford Aloha's domestic robot scenario. 3. Coordination strategies. During this experiment, 2 threads were executed in the Python program, each controlling one robotic arm, allowing the arms to perform independent actions. Alternatively, a leader-follower relationship can be established between the arms. In this case, only one thread would be executed in the Python program, controlling one arm, while the other arm follows the actions of the first. Interbotix offers various packages for coordinated actions among multiple robotic arms. However, we are not limited to using these packages and can explore additional coordination strategies independently. Troubleshooting. Common issues encountered. During our experiments, we identified 2 frequently occurring types of issues. 1. USB communication interruptions. Communication between the robotic arm and the computer via the USB port was frequently interrupted. 2. Servo malfunctions. The robotic arm consists of multiple servos, and occasionally, individual servos malfunctioned. Addressing servo issues. Since the Interbotix robotic arm is assembled by a US manufacturer and utilizes Korean-made servos, we employed the Dynamixel Wizard software provided by the Korean servo manufacturer. This software proved to be a valuable tool for troubleshooting both USB communication issues and monitoring the performance of individual servos. Benefits of Dynamixel Wizard. Free and open source, Dynamixel Wizard is freely available and open source, making it accessible to all users. User-friendly interface. The software boasts a user-friendly interface, simplifying the troubleshooting process.